Now we are going to discuss about introduction to LR parsing. It is nothing but the bottom up parsing, right? So as we have discussed in earlier session, bottom up parser is also nothing but LR parsing. So LR parsing is divided into 4 equal parts, that is LR of 0 items and SLR parsing. It is simple LR parsing, canonical LR parsing, that is CLR, and look ahead LR parsing. So these are of 4 types. So what is LR algorithm here? So the LR algorithm requires stack and the input and the output and passing table. So in all the types of LR parsing, input and output and stack are same, but passing table is different. We'll see the table. All the input output stack we are going to do the same process, but when we are constructing the passing table, it is going to be different. So we'll see that. So what is the block diagram of LR parser? It is a input buffer. It is used to indicate end of input and it contains the string to be passed followed by a dollar symbol. So a stack is used to contain a sequence of grammar symbols with a dollar at the bottom of the stack. So when we are entering into the stack, always we are starting with the dollar symbol. So passing table, it is a two-dimensional array. It contains 2 parts, that is first one action part and second one is go to part. So in LR of 1 items, we have various steps involved in this parsing technique. So for the given input string, we are going to construct LR of 1 parsing table, right? So for that, first we have to add the augmented production for the given grammar. Second step, we are creating the canonical collection of LR of 0 items. Third one, we have to draw the flow diagram, that is DFA for the given grammar. And last one, we have to construct a LR of 1 passing table. We'll see one example. So what is augmented grammar here? This is a step 1. The very basic thing is we are converting our given production into a augmented grammar. So augmented grammar G will be generated if we add one more production in the given grammar with the start symbol, right? So it helps the parser to identify when to stop the parsing and announce the acceptance of the input. So consider this example where the given grammar S implies A and A implies AA or B. Okay, so the augmented grammar will be represented as S dash. So here S dash implies S is. So here we have the start symbol is S, right? So we are creating the augmented grammar for the start symbol here. So S dash implies yes and S implies, so remaining 2 production we are taking as same. This is called augmented grammar. So second step is first one augmented grammar we have constructed, and now we are going to do canonical collection of LR of 0 item. So how to collect the LR of 0 items? So an LR of 0 item, it is a production G with dot at some position on the right side of the production. LR of 0 items, it is useful to indicate that how much of the input has been scanned up to a given point in the process of parsing. In the LR of 0, we place the reduced node in the entire row. So for example, for this grammar, we are adding all the dots. We have to pass each time, each item, we are passing these symbols. We'll see the example. So consider this augmented production. S dash implies dot S, S implies dot AA. For this production, for this augmented production, we are adding just a dots at the starting of the right hand side. So A implies dot AA, A implies dot B here. So consider this augmented production as I0 state. So add augment production to the I0 state and compute the closure here. So closure property is here is S dash implies dot S. So add all the production starting with S into I0 state, because dot is followed by the non-terminal. Always here dot is followed by non-terminal. So the I naught state becomes S dash implies dot S and S implies. So here we have the dot S productions we have to write in the I naught state. So I naught implies I naught is nothing but after dot we have S here. So what is the S productions here? S implies dot AA. So here S productions are dot AA. Okay. So and add all the productions starting with A in the modified I naught state because dot A is followed by the non-terminal that is A. So here we have added after dot S is there. We have added S production. Again we have after dot we have A non-terminal. So we have to add all the A productions here. So what are all the A productions here? A implies dot A implies dot B, right? So this is the I naught. This is constructed as I naught items. This is one of the canonical collection of I naught items. So what is I1? So go to when we are parsing on after dot, what are all the terminals or non-terminals we have to pass on that symbol. So in I naught state, what are after the dot, what we have is a and small b, right? So first we have to take S here because we are always starting with the starting symbol, right? So consider S here. So S dot, so that closure will become S dash implies after dot S is already passed. So it will become S dot. Okay. Here the protection is reduced to close the state. So after dot we don't have any non-terminals, any terminals here. So we are going to reduce to close the state here. So this is all about I1. Okay. So what is I2? S is already over. Again in I naught we have after dot A here. So A also we have to pass from go to I naught on A. We are moving to the S implies when we are passing on A. Okay. After this dot is moving to the next. Okay. See here. So that will become A dot A. So after dot we have again in this production A here. Okay. You should write all the A productions in the grammar. Okay. So what is the A production here? A implies dot A implies dot B. So the I2 will become S implies A dot A. Again dot A is there. So we have to write these two dot A productions here. So go to I2 comma A. So in I naught dot S is over. Dot A we have passed. Again we have small a here. So take the closure and A implies it will become A dot A will become A dot A. Again we have to what we have to do here, dot A productions we need to take because after dot we have here non-terminal. So non-terminal productions are A implies dot A implies dot B. So this will become another production. Okay. So again I3. So I naught on B again it is moving A implies B dot, right? So go to I2 B, it will become A implies B dot because after B we don't have any non-terminal here. So it is going to end the state here. Okay. So next take add the production starting with A in I3. So I1 no need to take from I1 because it is already ended. And from I2 what we have S implies A dot A implies dot A. So again we have to take after in I2 we have A productions and A and small b. These three we need to pass here. So what I3 will become so this will be over, right? So I2 on A again we are taking S implies A dot A here. S implies A dot A here. So I2 on A it will become S implies AA dot, right? S implies AA dot. I3 again in I3 will become A implies A dot A implies B dot, right? So in this way, we are going to construct all the canonical collection of LR1 items. So whatever the dot is there, after the, if we have the non-terminal here, you have to write that productions also. If we have after the dot, we have like terminals, we no need to take any productions, because with the terminals we don't have any productions, right? Okay. So until we get all the dots at the end of the production, until that time we have to parse here. See the construction of DFA. The DFA, it has contains here, we have states. How many states we got? I0 to I6, that is 7 states. Okay. So consider the grammar, augmented grammar, which is of I0 items here is S dash implies dot S dash implies dot A implies dot A. So after dot, what we have here is, so S we need to pass, it will become S dash implies S dot. Okay, so after dot again we have A, so we are passing here on A. So when you are passing on A, S implies it will become A dot A. Okay, so after dot again A here, A productions you need to take here in I2. Again in this we have small a, after dot we have small a, after dot we have small b. So this production will become A implies A dot A, because it is passing already over. So this dot will become one terminal. Okay. So A implies A dot A. So again after dot we have A here. So these A productions we need to take here. Understood? So again we have A implies dot B here. Okay. On the B, again we are passing, that will become, after dot it is passing. So A implies it is B dot. Okay, all the I0 items is passed now. So consider the I1. We have directly end of the state we have, because after dot here his dot, after dot we don't have any terminals or non-terminals in this I1 of 0, I1 items, right? So consider this I2. We have after dot we have A here. Okay, small a. Again we have small b here. So all three terminals and non-terminals we need to pass from the I2. So if it is passing from I2, S implies AA dot, it will become AA dot. So no need to take any new productions here, because it is already ended state. Okay. So next one, on small a it is moving, A implies A dot A. Again here it is moving on B, A implies B dot. Okay. Directly it is going to the existing state. No need to take any new state here. If it is same productions or repeating, you can directly map into that state. Okay. So what is I3? In I3 also, after dot we have A here, again small a, again small b. For small a and small b we have the same productions, only for capital A, that is non-terminal, it is moving to the other state. So A implies AA dot, it will become A implies AA dot. So all the items from I0 to I6, we have 7 items in our DFA. So how to construct a table? So first step we have constructed augmented grammar, and the step 2 is canonical collection of LR of 1 items. Then we have constructed DFA. Okay. So next last we are constructing the LR of 0 table. So how to construct this? If a state is going to some other state on a terminal, then it is correspond to a shift move. So we are defined with the letter S. Okay, if a state is going to some other state on a variable, then it is correspond to go to move. We'll see the table. If a state contain the final item, then it is in the particular row. Final item means these are I1, I5 and I6 are the final items here. Okay, if a state contains the final item in the particular row, then write the reduced node completely. Okay, we'll see. So I0 on A, I0 on A, it is moving. Where it is moving? I0 on A, it is moving I3. I3 means we have to write for this action S3 here, shift to move. Okay. So for I0 on B, it is moving I0 On B it is moving S4, that is shift 4. Shift 4. I naught on capital A, I naught on capital A, it is I2. So directly you can write go to I2. Okay. I naught on S, you can write I1 here. I naught on S, it is the first item, that is first one. Okay. I1 on dollar. If it is directly ended state, okay. If it is final state, so we can write directly it is as a accepted state. So these how we are going to construct a LR of one parsing table from this given DFA. So this is all about introduction to LR parsing and LR of one items, construction of LR of one items. Okay. So thank you for listening.